the non-volunteer groups. So the part is the table contents, you put the introduction, and then down to the result the passage and the application framework. We then go into the total for the part one and part two for the lab. Then we'll end the part one and include the introduction. So important concepts and formulas for this lab is the force of gravity, the electric field, and the force of electric fields from objects in space. So what is this lab? In this lab, we call the precipitation because we then see how different objects with different or alike charges interact with one another. We also see how the force of electrical charges and the force of gravity overlap with one another. So the results of our experiment. First, this is the first hit reaction to a hand. Next, we see the hope interaction time. And then we see the phase interaction with another piece of tape. So here's the code. So as you can see, this is the tape in part demonstrated as a point page. You see the magnetic density of the first on the magnetic electrical force calculated on the bottom. So here's the code. On the left, you can see the constant setup, and the box is 0.0000285 kilogram. And then on the right, you can see the math equations to figure out the force of the electric field. And the bottom, you can see how the series and the vectors are formed. The next part of the code, you found it as a line of charges. So you can see the magnitude of the force is the same as that of the gravitational force. So you can see the arrows and the vectors. Here's the code. On the left, it is the same essentially, but if the charges were estimated by me, so it can be the same the vowel A. On the right, you can see setting up the different values for the force, and on the bottom is how you set up the active force. So for some questions, what if and why? Electrons are negatively charged and protons are positively charged. What if the signs of their charges reverse, meaning if the electrons are positive and the protons are negative, what would change about the observations we made with Richards and other charged objects? I figured out that I don't think anything would change since if the charges were reversed, then everything would behave the same way since electrons still repel electrons and protons still repel protons, and electrons and protons are attracted to one another. So if these were changed, then nothing would happen in the experiment since the positively charged states were attracted to the negatively charged and protons. Compare the estimated value of the charge you get if you use your experiment data to deduce a point model charge to the value you got with the line model charge. The two computational values for Q will be different. Why will be different? Which values may likely be closer to the real value and why. I found that in the point charge model, my calculated charge is around 9.33 times 10 to the negative 931. And in my line charge model, my charge is about 2.57 times 10 to the negative 8. So these two are different because in a point charge model, you assume that the entire net charge of the tape is packed into its infinitesimally small point charge, roughly in the center, while in the line charge, they're distributed along the entire length, which is 0.2 meters. Because of this distribution, the charge segments on the outer edges and the bottom of the tape are circular segments by the top tape, so the diagonal distance is larger. Therefore, there will be a vector cancellation, causing the net electric force to be greater through all the vectors adding to the single point. To a single point now be known as a point charge alone in this case. Which is most likely to be correct is the line model because it's unlikely that a charge is actually just isolated into one particular small point, and it's more likely to be distributed around a line. So along that, like I was in the experiment. Okay. And this is the end of my lab. Thank you for watching.